Hey y'all, I get a lot of questions about my normal workflow when it comes to using VCarve Pro. And specifically, I get a lot of questions about importing a DXF file and then working it through, cleaning up that DXF, and then creating toolpaths and generating G-code. So I decided to make this video all about my workflow and doing just that. Let me apologize from the get-go for the length of this video. I really attempt to make these as short as I can, but when there's a lot of information to get out to you, that makes for a long video. I do try to edit them and make them as short as possible, but sometimes it's just not possible to cut it any shorter. So if you're willing to hang in here for a little bit, hopefully this will help you. So this is how I import a DXF file, clean it up, assign toolpaths, and then save G-code in VCarve Pro. Okay, and when we first start VCarve Pro, this is the screen we are greeted with. Now I'm going to create a new file here, and I know the size of the piece that I need. It is 8 inches wide, so I'm going to add an inch to that and say 9. And I know that it's 4 inches tall in the Y, so I'm going to add an inch to that and say 5. So there I have my workpiece. It is 3/4 of an inch thick. I'm not using an offset, so uncheck that if there is a check mark in it. For XY datum position, I make all of my parts, all of my files so far with my XY datum down here in the bottom left, and that's just because of the way I zero my tool out on the CNC. Some folks prefer to go for the center. Whatever you choose to use here, it's entirely up to you. There is no better or best. Just remember where you set your datum position, because you'll need to know that when you go to actually cut the part out. Okay, everything else looks good. My units is inches. These are fine, and we'll accept that now. So here is our piece of work material. Now the next thing I want to do is I want to import some vectors from a DXF file. So we go up to the File menu, come down to Import Vectors, and here is my DXF file. I want to use this one here, so I'll just double click it and it loads. With the DXF loaded, we can see that it's oriented vertically, and I need it oriented horizontally, obviously. So while it's all selected here and highlighted in pink, I'm going to come over here under the Transform Objects menu, and right in here, the third one in is Rotate. Now I'm not going to worry about the coordinates X or Y or anything else. I'm just going to go straight over here to the angle, and I'm going to rotate it 90 degrees. Click Apply, and it spins it around 90 degrees. I'll go ahead and accept that. Now I want to center the vectors on my workpiece. So I'll come over here again under Transform Objects to Align Selected Objects, and I want to align the vectors to the material both vertically and horizontally. So I go right here to the center icon, click it, and we see that it centers up the part in the material. Now I can go ahead and close this and accept it. Now I'm going to click somewhere just off of one of the vectors, doesn't matter where, to deselect everything. But there's a few things I need to check and a few things I need to get rid of. Number one, I don't need these center marks here, and they'll just confuse the issue. But I need also to make sure that all of these vectors are not separate lines, but are in fact joined. And the same thing with the circles. Not all DXF files are the same. Some of them a big vector like this, a rectangle here, will be joined. It'll be one piece, and you can check on that by clicking, and this one is. The rectangle is one piece. And we can come over here to one of the circles. It's also joined. There have been times I have found these circles to be just line segments and not joined at all. Then we come over here to this. Alright, and we see right here, right now, that this rectangle is not joined at all. It's separate line segments. Well, we need to join that. And the way we'll do that is to select all of the parts of this rectangle. So the way to select multiple objects, and there's several ways of doing this, but the easiest way is to do them individually, easiest way to start anyway. And so what I'll do is I'll just click on a line segment. Now then hold down the shift key and then go to the next segment and click it as well, still holding down the shift key, and just click away until I have all of that radius rectangle selected. Now, with everything highlighted, I can come over here under the Edit Objects menu, Join Open Vectors. Now when I look at this here, of my selected vectors, I have 7 open vectors. After joining, I'll have 1 closed vector, and that's what I'm after. So click Join, then Close. Now I can come along and click anywhere on this radius rectangle, and I know it's all one piece. Now let me throw a little tip here. To zoom out and put the workpiece and the vectors in the center of the screen, we'll go up here under 2D View Control. And you can see in the center here there's 3 different icons with zooms. If I click Zoom Selected and I don't have any vectors selected over here in my 2D view, if I click that, it zooms out and puts the entire workpiece in the center of the screen. If I were, for the sake of argument, to select this hole or this circle and click Zoom Selected, it zooms that circle to the center of the screen. So now if I click off of it and go back over to Zoom Selected, it puts the entire workpiece there. Now I need to get rid of these little crosshairs because it's just going to confuse matters, and I also want to check to see if there are any more open vectors. And the easier way of checking for open vectors is to go somewhere in the center here off of the vectors and right click, then come down to Select All Open Vectors. And you can see that it has highlighted all of my crosshairs. I don't see anything else in pink here, and I don't need these center marks or crosshairs. So I'll go ahead and go onto the keyboard and hit delete, and that removed all of those open vectors. Okay, so with all of the vectors joined, we can go ahead and group some, because some of these are going to use the same operation. Might as well cut them all at once, like all of these holes. So the way I do that is just select the hole. Now if you recall, in the other video I did on using Draft Site, I did this the same way. I'm holding down Shift as I do this and as I talk here. To select both of these holes here, I'm moving my cursor above and to the right of the vectors I want to select, and holding down the left click button, I'm drawing a box around and through the vectors I want to select. Now if I let go of the mouse button, you see both of those were selected even though this circle wasn't inside the box. When you're still holding the shift key down, when you're pulling from the right to the left, all the box has to do is touch the line. See, I can come all the way over here and it just touches that circle. I let go and it's selecting that vector. Now if I try to do that pulling from the left to the right, nothing. It doesn't do it. When you're pulling from the left to the right, the entire vector has to be inside that box. Then it will select it. So if you need to select something that's very close to another vector, you can come off of one side from the right to the left, and just so long as that box just touches one of the vectors in the object you're trying to select, it'll work. It'll select that vector. Okay, releasing the shift key now while I'm sitting there rambling. And I want to group these together so that they all fall under the same operation when we go to generate our toolpaths. So we'll go over here under Edit Objects and go down here to this icon that looks like it has a chain on the side here, and it's Group Selected Objects. Click that and you see they went from the dotted pink lines to solid pink lines on all of them. So now, click off to the side here. If I click on any one of these objects, it selects all of them. Okay, so now when I go to do my toolpaths, I can do the toolpath operation for this vector, then the toolpath operations for all of these, then the toolpath operations for all of these. I don't have to go in and do each individual circle. Okay, with all of these vectors grouped and all of the other vectors joined, we can move on to generating toolpaths. So for that, we'll go over here and switch over to the Toolpaths tab. Now, the order that you choose to generate your toolpaths is entirely up to you. The only time it really matters is when you go to put them in order to do the actual to save the G-code. Just for giggles, let's go ahead and do these holes. Now, in creating holes like this, I don't know that I have any bits that are exactly the right size to drill these holes. So generally speaking, I don't bother using the drilling toolpath. When I'm cutting a hole, I go ahead and tend to use a pocket toolpath. Now, in the pocket toolpath, I need to select my starting depth, which is 0, which is the top of the material, and I'm going to set my cutting depth for the same thickness as my material. So for that, I just on the keyboard type in Z equals, and it fills it in for me automatically. That way I don't have to remember how thick a material I have. Okay, the end mill that I want to use for this is I'm going to go with a 1/4 inch end mill, and I will go ahead and accept all of these settings here. Okay, 6 passes, that's fine. I don't need to use a larger area clearance tool with the 1/4 inch end mill. And to clear the pocket, I'm going to use an offset strategy conventional. It wouldn't make any sense to do a raster in a hole. So I'll go ahead and use the offset and let it spiral down. I'm not going to use an allowance, but I will ramp the plunge moves, and that distance doesn't matter. It's going to go in and cut it out in one smooth motion. All the rest of this, I'm just going to rename it holes and calculate my toolpath. And we can see the toolpath of where this is going to go, and I'll preview it now. And that looks good to me. It's a hole. Okay. Close that preview, go back to my 2D view, and we'll go to this guy here. Now for this, I'm going to do an inside profile. So I'll go over here to a profile toolpath. I want my start depth to be 0. I want my cut depth again to be 3/4 of an inch. So I type in Z equals. For my tool, I want to use a 1/4 inch end mill also. Oops, well, let's go back to that. Double clicking, obviously, on the tool means it selects the tool and closes this window. It basically means you're accepting everything here. I'm going to accept everything here, but I didn't know that until I went back and looked. Okay, 6 passes is good to cut this out. Now you'll see this green box right here. That's showing me where the vector start point is. That means over here it's going to use the vector start point. That's where the bit's going to plunge in and start cutting. So that's all that means. This is an inside profile, cutting conventional using the vector start points. Now here's where I do a separate last pass with an allowance of 0.01. Now what that means is, after this toolpath is calculated, when we get out on the CNC, the bit's going to come down and it's going to start making passes to cut this out along the inside. It's going to actually cut 0.01 of an inch large. Then on its last pass, it's going to move in that 0.01 and trim the full depth of it down to the correct size. I don't know if that made any sense. Hopefully it did. I use the separate last pass to kind of clean everything up in case there's any burning, and it eliminates the ramp steps from where the bit plunges in after each pass. Speaking of ramps, I'll want to come down here. I'm not going to add tabs, but I am going to add ramps to my toolpath. And I want a smooth ramp, and I want it to go of a distance of 1 inch. And what that means is the bit is going to start on this green dot here. That's the vector start point. My bit's going to come up over here and get over this point and start to plunge into the material, but it's going to plunge slowly and start moving along the inside of this profile line. It's going to plunge to the full cutting depth along the distance of 1 inch and reach its full cutting depth. Then it'll take off and start cutting around the inside profile. It'll get back to that starting point and then slowly plunge in again as it's moving forward, rather than plunging straight down. Many of you have heard me talking before about ramping your plunges. This is what I'm talking about. This is especially important if the bit you're using does not have a cutter all the way across the bottom. This is what I mean. Ramp in your plunges. Okay, next now is this is okay. Now I'm going to rename this, and just so I can keep it straight in my head, I'm going to call it the inside profile and calculate. Now we'll preview that selected toolpath, and there we go. Of course, you know, double click on the waste areas to get rid of it. Now we'll close this, and I have one last toolpath to do, and that's this one here. This is a standard outside profile. My depth of cut's already set. The proper tool is already set. correct number of passes, I need to go cut to the outside of this line. I'm going to cut this conventional. Yes, I'm going to choose the vector start point, and there's the start point here. So that means once this gets cut out, the bit will lift up and it'll move down to this corner and start cutting my outside profile. I'm not going to add tabs. I am going to ramp it in over a distance of 1 inch. I am going to do a separate last pass, 0.01, and everything else looks good. So I will rename this profile cut out and calculate. And we'll preview this toolpath, and there's our finished part. Looks good to me. Looks like it's going to work out just fine. Reset my drawing. We'll close this. Just something I prefer to do is I prefer to keep it on the 2D view when I'm working in this area over here. Now you can see how the word profile cutout, that's in bold. That means that this is the selected toolpath. I can come over here and select this one. I can come over here and select this one. Now, as I said earlier, we can put these in any order we want. We can generate these toolpaths in any order we want. But when it comes time to start thinking about saving G-code, you want your profile cutout to be the last operation that you do. Especially if you're using clamps or if you've got something screwed down to the table. Depends on how you mount your workpiece. You don't want to cut it out first and then not be able to do all this because the part is just lying there loose on the table. So your profile cutout should be the last one in line here. And the way this is running, it will run from top to bottom. If we generate toolpaths now, or excuse me, if we generate G-code now, it will generate the code for the holes, it'll generate the code for the inside profile here, then it'll generate the code for the profile cutout. That's fine. That's a good order. If we needed to move something around, you see these two arrows over here. Profile cutout is on the bottom. It's giving me the option to move it up. Now when I move it up to the middle, it's giving me the option to move it up or down. I can move it whichever direction I want. And the same thing with the inside profile. I can put it in any way that I want. Now this happens to be the order that I want to cut them in. I want to come in and drill my holes first, then I want to cut that inside profile, then I want to cut the entire thing out. So now, since all three of these are using the same tool, I can generate G-code by clicking this button here, which selects all three. Come up here to Save Toolpath. Now in the Save Toolpath window, I've got this check mark, output all visible toolpaths to one file. It's going to take my holes toolpath, my inside profile toolpath, and my profile cutout toolpath and save it to one file. I've selected my post processor. For my applications, it's the Mach 2/3 arcs in inches, which creates a .txt file. Then I'll come down here, click Save Toolpaths to File, and it's picked the first toolpath as the name. Now I'm not going to accept that name. I'm going to rename it. So I'll call it Demo Part. And it's in the correct folder. I'll save it. Now it's done. So close that. So that's it. That's my workflow, from creating a new project to importing the DXF file to making sure that all of the vectors are joined and eliminating the open vectors to generating the toolpaths and finally saving the G-code. That's about it. Now with a little bit of practice, you can get pretty good at this. Um, when I'm not creating a tutorial like this part here, this particular part, I time myself not giving instructions and explaining everything along the way. It took me less than 2 minutes to save G-code. So, and I've only been using this program for about a year. With practice, you'll undoubtedly get better than that. So just remember, there is no substitute for experience, and the only way to get experience is to practice. I mean, even if you're just drawing your name, that's good enough. So I hope you got something out of this video. If you did, give me a thumbs up down there, and I'll ask you to consider subscribing to my channel. And if you do that, you'll be notified every time I post a new video. Whether you subscribe or not, I'd like to say thank you very much for watching. You all have a nice day.